derivative with respect to time of this function. So I haven't evaluated the integral yet. So it's like saying, so it would be no different, for instance, say if I had, if this whole thing was 2t, I can write that as a derivative with respect to t of t squared. So I'm expressing this as because if you carry out this derivative, as long as you lump into 1/2, then this is what you would get. And I'm doing this so that I can conveniently cancel out the integral and derivative to get that. It's not necessarily the only way you could write it. Okay. Any other questions about this? All right. On time. Ooh, that's 6 minutes. All right. There's another example that I'd like to do. Okay. What is it? Ah, okay. Chalk is running down to 0. So this is 13.3, number 10 in Stewart. So you're given a vector field in 2 dimensions. So we have xy cosine xy plus sine xy. And the other component is x squared cosine xy. All right. So is it conservative? It's one thing to check. And then, if so, what is f? All right. Now, because we're running low on time, I will simply say that this does turn out to be conservative. If you differentiate this with respect to y and differentiate this with respect to x, then it actually does pan out. So, okay. Well, for form's sake, so we have product rule here. So we have y cosine xy minus xy sine xy. Okay. And then we have differentiate. Oh, whoops! I'm differentiating with respect to wrong variable, aren't I? So,
We would
okay.
have caught you at the beginning of class.
What?
We would have caught it if it was at the beginning.
Oh, okay. All right. All right. So, oh, the buck stops here anyway. So, okay. So x cosine xy plus xy sine xy squared. Actually, I was differentiating with respect to both x and y at the same time. And then here we have plus cosine xy with respect to y. That gives us an x out here. So this is py is equal to all this. These terms combine, so we get 2x cosine xy. Qx, we're going to get 2x cosine xy, which matches with this. And then we're going to have a plus x squared minus sine xy with respect to x. That'll give us y. So this matches with this. So everything works out. It really is conservative. So then to find the function little f, whose gradient is this vector field. So here's what you could do. You could define little f to be the antiderivative with respect to x of this function, xy cosine xy plus sine xy dx plus a function of y. You could do it that way, and why would you not want to? What? Yes. instead, we can do this. And this is why I picked this problem. Antiderivative with respect to y of the other component, x squared cosine xy, dy plus some function of x. And this is a whole lot more palatable. How would you go about antidifferentiating this with respect to y? So treating x as a constant. What would that turn out to be? Because there's only one y dependence there to keep track of.
X squared sine of xy over x.
Yes. So the x squared is as a constant, so you just carry it over. The antiderivative of cosine is sine, you have the xy, but because the antidifferentiating with respect to y, you treat x like a constant, so then you divide by x. So you get x sine xy plus some as yet unknown function of x. So now you take this and you differentiate it with respect to x and see what you get. So you're going to get, here you got to use a product rule unfortunately, so it's going to be sine xy plus x cosine xy squared plus h prime of x, and that's supposed to be equal to, wait, now you get xy, and differentiating with respect to x. So you get sine xy plus xy cosine xy, but that's exactly what we want. So h prime of x is 0. So that means that little f of xy is just this, x sine xy. So that, the gradient of that function gives you this vector field. So you differentiate with respect to x, you get this. You differentiate with respect to y, you get this, and it all works out. So it's tempting to say, oh, just take what you have, take the x component, anti-differentiate it with respect to x, but maybe it's easier to go the other way. So you can use whichever approach, as long as you're careful about keeping track of your variables. All right.
About the test, it's due Thursday, right?
Yes.
And Friday is Good Friday, so that doesn't count. Right?
So late days, Friday, Saturday, Sunday don't count.
Fine.
I mean, we were just going by